7.4, solving equations containing rational expressions. So we already saw a lecture with rational powers and rational roots. So this is going to focus on fractions again, specifically fractions with variables in the denominator. So now we're going to have to deal with x's while we're dealing with fractions. And so a valuable concept that will be mentioned a couple times in this lecture is the least common denominator. So that's what you need to do when you are adding or subtracting fractions. If you don't know how to add or subtract fractions, or it's been a while since you've done it, it might be a good idea to review a little bit what an LCD is, least common denominator is. But like outside of that, this lecture is pretty much problem solving with some, maybe a little bit of multiplication. Okay, so with that in mind, here's a simple fraction with, yes, we have x's in them, but they're all in the numerator. So if we were to solve this question, we could kind of go about moving fractions around and adding and subtracting fractions. But we can actually use this neat little trick of, if we can identify what the LCD is, in this case, it's 20. If we can identify what each denominator fits into, then what we can do is we can actually get rid of all of the fractions. So I know my LCD in this case is 20. 4 fits into 20, 5 fits into 20, and then of course 20 fits into 20. So what I can do to get rid of all of my fractions is I can multiply everything by 20. And since 20 is a whole number, it's really multiplying just the top of the fractions by 20. So I distribute that all the way through every single number. Even if it's a whole number, I'm still going to multiply it by my LCD. So in this case, I'm left with 3x times 20 is 60x, 4 times 20 is 80, 7x times 20 is 140x. And now I just simplify everything. 60x divided by 4 is 15x, 80 divided by 5 gets me 16, and 140x divided by 20 gets me 7x. Great, now I have no more fractions to deal with, so I just go about solving it as though it's a regular equation. In order to do that, I would get all of my x's on one side, so I subtract 7x from both sides. Then I subtract 16 over, and then I divide both sides by 8, and I get x is equal to -2. Now, just like when we were solving with square roots, when we're dealing with fractions, it's the kind of the case 1 of the domain versus case 2, I need to always check my answer. I can do everything correct, and there is a possibility that my answer will not work. So I have to go back to the original question and plug it into each part, each place where there's an x. I plug it into my first fraction and my last fraction. I'll get -6 over 4 plus 5 over 4 is -17 over 20. If I add the fractions to the left, my common denominator is 20. I would get -14 over 20 is equal to -14 over 20. Yes, I should reduce it, but really when I'm checking answers, I'm just making sure that there's equality. So there is, so my answer did work. I can go ahead and box my answer. Now things get a little bit trickier when we're dealing with variables in the denominator, but the process is exactly the same that we did with the last problem. I need to identify my LCD, and it's a little bit tricky to think about, but in this case, I have to think about a number that 5 fits into, 5x fits into, and x fits into. And kind of the easiest way to do that is look at the numbers. Well, both numbers fit into 5, and then look at the variables. Well, it's a single x, both of those fit into a single x. Maybe if there was an x squared, I would have to go to a higher power, but there is just single x, so my highest number is 5, my largest variable is x, so 5x. Well, my lowest number that 5 fit into. Now, I take my LCD, I multiply every number by 5x, and specifically the numerators by 5x, same process. So I get 30x over x minus 5x times x plus 30. And you might be thinking, oh, I could actually just distribute that middle fraction and get a quote-unquote nicer expression. Actually, wait for that when you're doing this problem-solving process, and I'll explain in a second. And so my last one would be 5x times 2, or 10x if you wanted to. Now, what's going to happen is if you're doing things correctly, all of my denominators are going to cancel out. So my 30x divided by x just becomes 30, and my 5x cancels in the middle fraction. So that's why I didn't multiply it out, because I got rid of it immediately and I saved myself a couple of steps, and it's actually easier to see that they're canceling. And then I do my 5 divided by 5 also cancels out, which gets me 2x. And yes, you could have multiplied the last fraction and gotten 10x divided by 5 gets you 2x. That's perfectly fine. Really, I don't want you to FOIL it out or distribute, because then it's very hard to see what actually cancels. And now I just have an algebra problem. Just go about solving it. I just distribute my negative to both things inside my parentheses. I get all of my x's on one side. Ooh, I might cancel my 30 first. Yeah. 30 minus 30 gets me 0, so I cancel that. I'm left with negative x is equal to 2x. I add x on both sides. I divide both sides by 3. X is equal to 0. Now, I need to check my answer, but there's a clever way I can check my answer when I'm dealing with these fractions. And that clever way is to really see, does that value make it so any of my denominators are 0? Because that's the only thing I'm really concerned about with these rational expressions, is I'm not allowed to ever divide by 0. So I could go back and plug x into, or plug 0 into every single x and try and solve it, but what's going to happen is we can even just look at that first fraction. If I plug in x into the bottom of 6 over x, or if I plug in 0 into the bottom of that first fraction, 6 over 0, well, now I get 0 on the bottom, which I'm not allowed to do. So I conclude there's no solution. Got a little bit more complicated of a question here. And so for starters, if we do have things that look like they could maybe factor, we should factor them as much as possible, because there's a good shot this question is designed to make it so that we don't have a really disgusting LCD. So I see my x squared minus 5x plus 6. I'm going to factor it to see if maybe the factors have anything in common with the other fractions. Well, in fact, they do. Oh, yeah. Well, in fact, they do. I got x minus 2, or negative 3 times negative 2 gets me positive 6, adds to get me negative 5. So my first fraction factors to that, x minus 3, x minus 2. Well, now all of my factors, all of those denominators fit into x minus 2 times x minus 3. So my LCD is exactly that. If there was an additional thing, like if I had x plus 5 on the right fraction, I would have to include that with my LCD. Or even if I had an x minus 2 squared on my last fraction, I would have to make it a square in my LCD versus what it is. But if you can combine everything and everything fits into that LCD, my x minus 3 is there, my x minus 2 is there, and then obviously my entire x minus 3, x minus 2 is there, that is going to be your LCD. Now I'm going to multiply all of my numerators by my LCD. And again, I'm not going to try and FOIL, I'm not going to try and distribute, I'm just really going to place them on the numerator, and then I'm going to go through and see how much I can cancel. If I'm doing it correctly, I should be able to cancel out every single denominator. So my first fraction, my x minus 3's cancel out, my x minus 2's cancel out. My second fraction, my x minus 3's cancel out. My last fraction, my x minus 2's cancel out. And so all I'm left with is actually a fairly simple equation. I'm left with an x, 4 times x minus 2, and 3 times x minus 3. I go through my problem-solving process. Now I'm going to distribute. So I'm left with 4x plus 4x minus 8 on the left side, and 3x minus 9 on the right side. Combine like terms on the left side. I move the 3 over. I add the 8 to the other side. So 5x minus 3x gets me 2x. Negative 9 plus 8 gets me negative 1. I divide both sides by 2, I get x is equal to negative 1/2. Now again, I could go back and plug in negative 1/2 into my original equation. That's actually a very big headache in this question, because we have a lot of x's flying around. We have a lot of we have a square going on, we have things we can FOIL, we'd have to. The long and short of it is, it's difficult. It's doable. If you want to do it, but it's difficult. But instead, I can look and say, okay, well, my LCD is x minus 3 times x minus 2. So really, the only numbers I need to be concerned about avoiding are 3 and 2. So if I have those numbers, yes, they don't count. They're not a solution that works. But in this case, negative 1/2 is not 2. It's not 3. So this answer actually works, and I can go ahead and box my answer. By the way, if you find an answer that doesn't work, I may have mentioned this before. If you find an answer that doesn't work, don't erase it. Don't scribble it out completely. Just go ahead and put a slash through it. That's all I want to see, because I do want to see that you got to that answer. I just want you to be able to recognize, okay, yes, this is not an answer, / yes, this is an answer, box. Solving literal equations. So we're going to see this a couple times through the semester. And so when you're solving literal equations, it's kind of a weird phrase to think about. Really, it means that you're going to be solving for a variable, and there's a good shot you're going to still have variables on the other side of the equation. It might not be very nice. So in this case, if it's telling you to solve a literal equation, it has to tell you what to solve for. So I have my equation here, and I'm told to solve for my y. So I want to get y by itself. Well, I have y in the denominator, which is always difficult to deal with. And, well, you may realize that, well, in this section, we've been using kind of the same strategy. So there's a good shot we're doing the exact same strategy here, and you would be right. I have fractions. I don't want to deal with fractions. I'm going to identify my LCD. In this case, my LCD is actually just all the denominators multiplied together, since they don't have anything in common. So my LCD is XYZ. And so I'm going to multiply all of the numerators by XYZ. So I just get all of my fractions, XYZ on top. Now I can go through and cancel. My first fraction cancels my X. My second fraction cancels my Y's. And my third fraction cancels my Z's. So this is what I'm left with. Now my goal is to get Y by itself. Right now I have Y on both sides of the equation. So I'm going to subtract YZ from both sides. Now it's still kind of hard because we're thinking, okay, I want to get y by itself, but now I have two y's. It'd be really great if maybe I could only have a single y, so then I could actually solve for that single y. Well, we can do that by factoring. We're going to factor out the y out of both terms. So we're going to have what xz is equal to x minus z times y, and then I'm going to divide both sides by x minus z. So y is equal to x times z over x minus z. By the way, solving literal equations is valuable, and we'll see it again. This question is particularly tricky, and so I think it falls into the category of it's probably one homework question. I would be surprised if it showed up on the test. I can't predict the future, but I would bet a decent amount of money that this would not show up on the test. So understand the concept. We'll see it 2 or 3 more times in the semester. Don't get caught up on the very specific individual details because there's a lot of weird things flying around in this question. Really focus on the other examples in this section. And that's the end of this section.